Hey everyone, welcome back to the channel. I hope you guys are doing pretty well. So we have a pretty simple problem for today's daily challenge. So let's see and solve it together, and also we will try to solve it in an optimized way. So let's see. Special positions in a binary matrix. Given an m cross n binary matrix mat, return the number of special positions in the mat. So position I comma j is called special if mat of I comma j is 1, and all the other elements in the row I and column j are 0. So it means that there is only a single one in the whole row and the whole column, and that particular I and j is called special. So if you think of this example one, in the first look at this first one, you see this is a one, but in the row there is no other one, but in the column there is another one. So this cannot be a special position, okay? But if you talk of this second one in the second row at the last, you see that this is the only one in the whole row and as well as in the whole column, so you can call this as a special position. And also for this third one, there is one in the column, so you cannot call this as a special position. But in example 2, if you see, so in example 1 you simply return 1 as your answer, but in example 2, uh, everyone, for everyone, all the rows and all the columns does not have any one, okay? You see, the row and column in which they are situated, do not have any one in it, so they are the only ones, okay? So you see there are three positions that are special, so you output 3. So you need to output the number of special positions, and m and n are just 100. So a brute force solution which should come to your mind at first, and which will absolutely work in this case, is an O of n cube solution. So you iterate through every element in this matrix. Whenever you encounter a 1, you also iterate towards the right using one for loop, and also you iterate through these rows as well as through the columns through another for loop, okay? And you check that whether any one is there or not. If any one is there, you do not uh, take that as a special position. Otherwise, you can take that as a special position and increment your answer plus plus, okay? But I will try to tell you that try to think of an O of n square solution only. Yeah, so I hope that will work fine. And uh, you should think of an O of n square solution, okay? Because O of n cube will be too much obvious. So solving this is n square, you can map the values, okay? So you see, you want to find the number, the row number and the column number, which is special, okay? So two maps you can select. So let's say you have a row map, okay, and you can have a column map. This can tell you that in the ith row, how many ones are there. So if there are 3 ones in the ith row, it will tell you 3. If there is 1 it will tell you 1, okay? And in also for column, in the jth column, how many ones are there, okay? If there is 1 it will tell you 1. So how many ones are there? So index comma count of 1, this will be your uh, key comma value, okay? In this way, you can just iterate through this matrix. So you can have a for loop I, okay, and you can also have a for loop of j, and you can just do something like row map of this is iterating through the rows I plus plus. We'll just go to the index I and increment a value of 1, okay? And in the row column, you can just increment this, okay? So this will help you store that uh, if any one is there or not. But if matrix ij is 1, then only you do this, okay? If matrix ij is 1, then only you do these two things. And while iterating once again, so you can have another for loop, okay, 0 to, let's say, m, and for another int j, 0 to n. What you can do, if you find matrix of ij is 1, then if matrix ij is 1, you find that, then you also check whether and row map of I is also 1. So this means that the current value in the matrix in I comma j position, if that is 1, and in the whole row map there is count of 1, okay, count of this I at this position I in this whole row, there is only 1, okay, and also in the column map, also the count of the number of ones is 1, okay, that is the number itself. Then you can simply increment your answer. I hope you do understand, and at the end you can simply return answer. I hope you do understand what I mean. So you just counted in a particular index of the row and column how many ones are there, and later when you are finding a one in the position, you just see that whether that is only the unique one in that position. If that is true, then increment your answer, and at the end return answer. Okay. So yeah, I hope you understood the solution. You can try to code it out on your own also. And if you think you have understood, you are free to drop off from the video. Okay. So let's have integer m and n. Yeah, and n will be mat of 0 dot size. And you can have an unordered map. As you know, unordered map stores an amortized O of 1 time complexity. So you have unordered map, but we need to have two map, row map and column map, right? As I told you, row and column. And yeah, so while having an iteration, I from 0 to m and j from 0 to n, right? And if you see that matrix of ij is 1 anywhere, then what you can do, you can have row of I plus plus. You can also have column of j plus plus, okay? And yeah, so and after this, you can have an int answer initialized to 0 and return answer at the end. But to compute answer, what can you do? For int I0, I less than m, I plus plus, and also for j0, j less than n, j plus plus. If you see a matrix and I comma j position, if it is 1, and you want to see that whether that's a unique one in the position I also. So whether row I also has one, the count of the number of ones in this row is 1 or not, and the count of the number of ones in this column is also 1 or not, then that is the unique one in that row, and you can simply increment your answer. And after all this, you have already returned your answer, right? So yeah, that is all. If you try to run, I hope it will work just fine. So let's see. Yeah, it worked, and let's try to submit it for all cases. I hope it will work pretty well. Yeah, so you see, it would have been accepted by an O of n cube solution also, but you are doing an amortized O of 1 with this unordered map. So you are essentially doing a time complexity of O of n square. So yeah, that is all for this video. I hope the concept was really simple to understand. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.